Hello, this is session 2 and lecture number 19 for day 19, and today we shall discuss about some important numerical based on the theory which we have discussed earlier. The first question which I have selected, that a parallel plate capacitor with air between the plates has capacitance 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with a substance of dielectric constant 6? This is the first question, and now the solution of first question is this. The solution of first question, we know that the capacitance of capacitor is given to us, which has formula epsilon naught A upon D is equal to 8 picofarad. Now D dash is equal to the capacitance, the separation of the plate is reduced by half, means D dash is equal to D by 2, and the value of dielectric constant is equal to 6 is introduced in the capacitor. Now the new capacitance will be C dash is equal to epsilon K epsilon naught or epsilon A upon D dash. Now we shall put the value, instead of epsilon we shall put K epsilon naught A upon D by 2. So 2 K epsilon naught A upon D, and now C dash is equal to 2. The value of K is 6 given to us, and epsilon naught A upon D. So 12 into epsilon naught A upon D has the value 8 picofarad. So the answer of or capacitance of the new situation will be 96 picofarad. This is the answer of the first question. Again I am explaining, the capacitance of capacitor is given to us at picofarad. D dash is equal to D by 2. The first situation is given to us, in which the plate, if the distance between the plate is reduced by half and the space between them is filled with a substance of dielectric constant 6. Now we shall put the new capacitance. We consider the new capacitance C dash is equal to epsilon A upon D dash. The value of epsilon will be K epsilon naught A, and instead of D dash we shall put D by 2. So the value 2K epsilon naught A upon D, the value of 2 is 2 and the value of K is 6 epsilon naught A upon D. The value of epsilon naught A upon D is 8 picofarad. So the answer will be 96 picofarad. This is the solution of first question. Now we shall discuss the solution of second question. It was the first. Now the solution of second question, question number, and solution of 2. 3 capacitors of capacitances 2 picofarad, 3 picofarad, 4 picofarad are connected in series, then in parallel. What is the total capacitance of both combination, and what is the potential difference across each capacitor in series combination is connected in 120 volt supply, and what is the charge on each capacitor if the combination is connected to 100 volt supply? This is the question based on the capacitance combination of capacitors, and here are the values of C1 is equal to 2 picofarad, C2 is equal to 3 picofarad and C3 is equal to 4 picofarad. For the case of series combination, we know that 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. The value of 1 by 2 plus 1 by 3 plus 1 by 4 and 1 upon picofarad. Now taking the LCM will be 12. This is 6 plus 4 plus 3 and the value of Cs is equal to 1 upon picofarad as usual will come, and the solution will be 12 upon 13 picofarad. So the capacitance will be is equal to 13 upon 12. 13 upon 12, 1 upon picofarad, and the Cs means equivalent capacitance of capacitor will be 12 upon 13 picofarad. This is the equivalent capacitance for the series combination. And now we shall discuss about what is the total capacitance, about what is the potential difference across each capacitor in series combination, and the potential is given to us 120 volt supply. So we know that Q is equal to VCS, the value of V is 120, the value of CS is 12 upon 13 picofarad. So in this manner the total charge will be is equal to 1440 upon 13 picofarad. 12 upon 13 picocoulomb. This is the total charge supplied by the cell to the combination in series combination. Now we shall discuss about the V1, or V1 is equal to Q upon C1. The value of Q is 1440 upon 13 into 10 raised to the power minus 12 upon the value of C1 is 2 picofarad. 2 into 10 raised to the power minus 12 and minus 12 cancel out, and this is equal to the value will be 720. So the value of V1 will be is equal to 720 upon 13 volt. The value of V2 will be is equal to again Q upon C2. The value of Q is 1440 upon 13 into 10 raised to the power minus 12 into 3 into 10 raised to the power minus 12, minus 12 and minus 12 cancel out, and this will be is equal to 480. So 480 upon 13 volt will be the answer for the second potential. And now we shall discuss about the V3. Q upon C3 is equal to 440 upon 30. This is 10 raised to the power minus 12 as usual will come, into 4 into 10 raised to the power minus 12, minus 12 and minus 12 cancel out, and now we divide 1440 by 4, it is 360. So 360 upon 13 volt. This is the potential of the at each capacitor when the combination is series combination. Now we shall discuss about the parallel combination. Now we shall discuss about the parallel combination. In parallel combination, Cp is equal to C1 plus C2 plus C3. The values are 2 plus 3 plus 4 picofarad. So the capacitance will be is equal to 9 picofarad. This is the equivalent capacitance of the capacitor in parallel combination. Now we shall discuss about the next, what is the charge on each capacitor if the combination is connected to 100 volt supply. So we have calculated Cp is equal to 9 picofarad and potential is given to us 100 volt. So the value will be is equal to, or we know that the value of Q1 is equal to V upon C1. The value of V, Q is equal to CV. Q1 is equal to CV1. The value of C is C1V. The value of C1 is 2 into 10 raised to the power minus 12 into the value of V is 100. So the answer will be 200 into 10 raised to the power minus 12 coulomb. The value of Q2 will be is equal to C2V. The value of C2 will be is equal to 3 into 10 raised to the power minus 12 due to picofarad. And now the value is 100. So the answer will be 300 into 10 raised to the power minus 12 coulomb. And the value of Q3 will be this. Q3 is equal to C3V. The value of C3 is 4 picofarad, 4 into 10 raised to the power minus 12 due to picofarad, and V is equal to 100. So the answer will be is equal to 400 into 10 raised to the power minus 12 coulomb. So the answer of Q1, Q2 and Q3 are the values. Q1 will be is equal to 2 into 10 raised to the power minus 10 coulomb. Q2 will be is equal to 3 into 10 raised to the power minus 10 coulomb, and Q3 will be is equal to 4 into 10 raised to the power minus 12 coulomb. These are the answers of the question number 2 in parallel combination, in which we have calculated the equivalent capacitance and then charge on each capacitor where the supply of 100 volt is given to us. And earlier we have discussed about the series combination also. Now we shall discuss about the question number 3. The question number 3 is based on the energy of capacitor and loss of energy due to recombination. And for the solution, of question number 3. A 600 picofarad capacitor is charged by 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? So first of all, C1 is given to us 600 picofarad and the supply is given to us V1 is equal to 200 volt. This is the supply given to us. Now we shall calculate the initial electrostatic energy of capacitor. U1 is equal to half C1 V1 square. So 1 by 2. The value of C1 600 into 10 raised to the power minus 12 into V1 square. V1 square means 200 into 2 and this is cancelled out. Now we obtain the value of 6 to the 12 into 10 raised to the power minus 6 joule. So this is the initial potential energy of capacitor were calculated by half C1 V1 square, and it is 12 into 10 raised to the power minus 6 joule. Now we shall discuss when this the another is C2 is equal to 600 capacitor picofarad, and it is uncharged capacitor, means V2 is equal to 0 and this capacitor is connected to the first capacitor. So the equivalent common potential will be is equal to C1 V1 plus C2 V2 upon C1 plus C2. The value of C1 is equal to 600 into V1 is equal to 200 plus 600 into V2 is equal to 0 upon 600 plus 600 into 10 raised to the power minus 12 into 10 raised to the power minus 12. So this value is 0. So again for the common potential, V is equal to 600 into 200 into 10 raised to the power minus 12 upon 1200 into 10 raised to the power minus 12. Minus 12 and minus 12 cancel out, and this value and this value is cancelled out. 2 6 12 and 600 calculated. So the common potential of both the capacitor will be obtained 100 volt. This is the value of common potential. Now we shall calculate the final potential energy, electrostatic potential energy, and it will be is equal to 1 by 2 C1 plus C2 into V square. So value of UF is equal to 1 by 2 into 600 plus 600 into 10 raised to the power minus 12 into 100 into 100. So UF is equal to 1 by 2 into 1200 into 10 raised to the power minus 12 into 100 into 100. So UF is equal to 1 by 2 into 1200 into 10 raised to the power minus 12 into 100 into 100. 600 is this. So UF is equal to 6 into 10 raised to the power minus 6 joule. So this is the initial potential energy, and this is the final potential energy. And in this manner the energy loss is, because initial energy is greater, final energy is smaller. So energy loss delta U is equal to UI minus UF is equal to 12 minus 6 into 10 raised to the power minus 6 is equal to 6 into 10 raised to the power minus 6 joule, will be the loss of energy in this process.